Hello all, this is Priyadarshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today in this video we will explore what is regularization under deep network basics. So in this video we will be exploring what is regularization and how these deep neural networks often overfit the data and how these regularization models help the deep neural network models to generalize when an unforeseen data set has arrived. So in this video, we will discover what is regularization and the different types of regularizations like L1 regularization, L2 regularization, early stopping, dropout, and even we are going to see about data augmentation. Let's explore. Before getting into regularization, first let us understand what is deep feed-forward networks. So as we all know, deep feed-forward networks form the basis architecture for your deep learning. So these deep feed-forward network consists of multiple hidden layers. So you have many hidden layers. As the name suggests, it is deep feed-forward, and you have the feed-forward network only for prediction. You have nonlinear activation functions, and the training is done by backpropagation. So these are the main things about deep feed forward networks. As we all know, if the number of hidden layers, if the number of parameters and the data are increased, the network models can learn better. But the capacity increase itself will have some challenges. Let's explore what are they. Let's see the challenges of high capacity. So deep neural networks are highly powerful because they contain millions of parameters as we know. While this allows them to learn complex patterns, it can also cause a problem called overfitting. So overfitting occurs when the model memorizes the training data instead of learning generalized patterns. As a result, the training accuracy becomes very high. The performance on new or unseen data becomes poor. To overcome this issue, we are going to see what is regularization. Let's see the need for regularization, or let's define the regularization technique. So as we all know, regularization is a technique that is used to control the complexity of deep neural networks in order to avoid overfitting. So the main goal of regularization is to make the model learn the training data more effectively rather than memorizing it. So in simple words, a simplified regularization model will have a right mix of the right balance of the network. That is, it makes the network learn the meaningful patterns as well as it improves the performance of the model when an unforeseen data has come. So this is the main goal of regularization. So we will discover what are the different types of regularization available. The first regularization we are going to learn is L2 regularization. In other words, it is also called as weight decay. So what does it do is, it controls the model complexity by penalizing the large weights. That is, when you have a loss function 2 5, then the penalized term will be 25. So whenever we have a large function, we will be penalizing the model by a very large term. So that the model will be very simple. It makes the model to learn properly, not to memorize. Only the meaningful patterns will be taken, and it will not memorize. It will generalize the loss function, and also it will make the model complexity a very small. So what does it do here is, the penalty term is added to the original loss function. So the loss function would be, the penalty term will be squared. So that is why we are having a large weight is penalized. So this model encourages smoother simple models, so that single weight does not become a dominant feature. Also, it prevents the model from reacting too sharply when the noise in the training set is large. So the next type is L1 regularization. So here the penalty term is added to the loss function with the help of the absolute value. So this model helps to achieve an efficiency through sparsity. So this model's efficiency is through sparsity. So here this model produces a sparse model. That means many of the weights will be reduced to zero. If that particular item is not valid, then it will make it to zero. So here the functions are an inherent feature, selecting and very inefficient, identifying the most critical variables for the model success. So this is about L1 regularization.